Hello and welcome to homework helper number 9.5. Let's go ahead and look at what we're going to be doing today. We had a pretty intensive activity planned for today in class. So this is kind of building on that. I will try to touch on some of the concepts we covered in class as well. But if you're missing some of that important information because you were gone today, you will have to either see me or see one of your group members to try to make up some of that stuff. But let's go ahead and dive in. We have estimating the line of best fit. So we're going to examine the scatter plot, and then we're going to imagine we drew a straight line through the general pattern of the points, keeping it as close to possible to all points with as many points as above and as below. So we want to try to predict what this line would look like. So when I look at this, I see that it has a negative slope and it's traveling something like this. So if I were to take a guess, trying to balance it as best I can, whoopsie, I would draw a line that looked kind of like this, kind of like that. I might actually move it down a little bit lower, but that's close enough for jazz. So when I look at this, it's asking me a couple questions. It wants to know what my y-intercept is. Well, I ended up having it cross right here, which would put me at about 103, right? That would be 103 if this is 102. And then it wants me to figure out what the slope is. I'm like, oh boy, what is that slope? So to do that, we're just estimating. But based on this line, I can kind of figure out a rise over run. So if I go to 5, puts me at right here, which is 100. So this point right here is the point 5, 100, whereas this is the point 0, 103. So from that, I can calculate my slope using my slope formula. So if I do y2 minus y1 all over x2 minus x1, which would give me 100 minus 103 all over 5 minus 0, giving me a negative 3 over 5. So my slope is a negative 3/5. Your slope, depending on how you drew your line, depending on how you eyeballed where it crosses, may vary. Okay? Oh, and then it says sketch the line. I guess I did it backwards. I flipped these. I guess for me in this particular point, it made a little bit more sense for me to kind of visualize that line. But actually now that I drew it, and I said this before, I would probably move it down a little bit. It would probably look a little something closer, like maybe a little flatter, something like that. Anyway, this is again just making sure we see how a line could be the average of all that data, that best fit line. Okay, let's go ahead and move on to the next one. So we have these correlation coefficients that's given to us here. So let me go over real quickly what our criteria is for correlation coefficients. Okay? So when we're talking about correlation coefficients, we're looking at two different axes of comparing them. The first is whether or not it is positive or negative. A positive correlation coefficient will appear to move upwards like a positive slope, whereas a negative correlation coefficient will appear to move down as though with a negative slope. Now the degree to which it is positive doesn't really matter, the slope of it doesn't matter, but as long as it is a positive relationship, same thing with negative, the degree to which it is negative doesn't matter so long as it is negative. The other thing that we are looking at is we are going to be looking whether or not it is close to 0 or close to positive or negative 1. If it's closer to 0, this is a less strong correlation, or you might say weak correlation. If it is closer to 1, we would say this is a stronger correlation. Okay. So essentially what we're looking at here is we're looking at this kind of matrix. So if I had like a negative 1 to 1 continuum, and this is my 0, I would say that if my correlation coefficient fit anywhere within the orange here, this would be weak. It would be weak if it were in the orange, and it would be strong if it were in the purple. Strong. Okay. Just one way of thinking about that. This kind of visual will be really helpful as we look at this. So we're given a whole bunch of correlation coefficients, and we're asked to look at a couple of examples and figure out what the correlation could be. Okay, so let's go ahead and start with number 3. Now when I look at number 3, I see it appears, as we go left to right, it appears to be negative. And it appears to be pretty tight, except for this guy. It's pretty tight together. So I would imagine this would be a strong negative correlation. So thus, I would be anticipating a correlation coefficient closer to -1 than it is to 0. So when I look at my possible options, I see I have 3 negative correlation coefficients. I have one that's a negative 0.94, a negative 0.49, and a negative 0.25. This would be less strong, so I'm going to eliminate that. This would be kind of medium strong, and I think that this one, like, it's almost a straight line. I would say that this is very strong, so I would say that the answer would be C. Almost a perfect negative correlation, negative 0.94. So that would be my answer there, C. Okay. Zoom out a little bit. All right, so let's look at this one here. So now I'm looking at this one. Oh boy, what's going on here? So for this one, we have this little tail end here, which makes me think it's negative, but it's not. This is one of the weakest correlations I've seen. It kind of just feels like a box outside of that. So I would say this would be a very weak negative correlation. And so I would expect this to be a number that is closer to 0 but still negative. So closer to 0 but still negative would probably be this F value that we eliminated earlier. Okay? And so that's pretty much how we're going to do this. Every time you look at one of these, you're going to figure out, is it a strong or weak correlation, and is it a positive or negative correlation, and find the number that best fits that. Cool. All right. Final point. We are going to be looking at visually comparing slopes of line. So this is just thinking about things in terms of whatever input they're giving us. This is asking us to find a line that has a greater slope than this number here. We can do this by calculating slopes. We can do this by just eyeballing it. It doesn't really matter. We can see it crosses perfectly here and here. So we go up 1/3 is our slope. So we just need a slope that's a bigger number than 1/3. So how about, I don't know, 2/3? That's a bigger number, right? So I'll do the exact same line. I'll even have it cross here, except this time I'm going to go up 2/3. And so what we see here is that a greater slope has a greater incline, right? The larger number makes it bigger. Whereas for this one, we want a lesser slope. Well, this has a slope of 0. It's not going anywhere. So if any negative number slope would give me a line like this. Right, there we go. And that's it. It's just being able to play with it in terms of comparing greater, lesser, larger, smaller, et cetera, et cetera. Okay. That should do it for you guys. Good luck on your homework tonight, and I'll see you tomorrow.